Let's figure out the speed of a recursive algorithm using guinea pigs. We will be using the substitution method to solve this. Analyzing algorithms is all about time complexity, space complexity, and correctness. Let's break it down step by step. First step is to identify a recursive relationship. Let's take a look at this example. The input is n, which is the number of guinea pigs. The process is printing each guinea pig and reducing n by 1 each time. And the base case is when n equals 0, which means there is no more guinea pigs left to count. Now let's plug this into the recursion formula. This is a math equation that describes how long a recursive algorithm takes based on two things. 1, the smaller problems it calls itself on, and 2, how much work it's doing outside that problem. We know the base case, which is when n equals 0, and when we print the number of guinea pigs, that is the constant work. Then when we call the count guinea pigs method, that is the small problem. So we have one recursive call on n-1 and constant work each time. So this is what the formula looks like. You can think of it as time for n guinea pigs equals the time for n-1 guinea pig and extra content work. So how do we solve this using substitution? We know the recurrence is t of n equals t of n minus 1 plus c as long as n is greater than 0. This means when n is greater than 0, you can replace t of n with t of n minus 1 plus some constant work. As long as the input is greater than 0, t of n minus 1 itself also follows the same rule. That's why we write n minus 1 minus 1. We are applying the reoccurrence again. Now that we know t of n minus 1, we can plug it back into the original equation. Now we do the same exact step, but this time with t of n minus 2. Now plug that into the equation. We get t of n minus 3 plus 3c. Now let's substitute for t of n minus 3. You've probably noticed by now a pattern. After k steps, we've unrolled down to t of n minus k, with each step adding a c. So the general pattern is t of n equals t of n minus k plus k times c. We stop unrolling when the inside hits the base case. So that means this happens when n minus k equals 0, which means k is n. So by plugging in the base case, which is t of 0 equals d, we get t of n equals d plus c times n. That is linear time because we dropped the constants.